Look at number 6 in section 3.3. We're using the quotient rule to calculate the derivative for this function. F of x is e to the x divided by x to the fourth plus 1. Just a reminder of the quotient rule. We have the derivative of one function. I'm calling that top function u of x, the bottom function v of x. So the derivative of the top is u prime of x. The derivative of this is the derivative of the top function u prime of x times the bottom function v of x minus the top function times the derivative of the bottom function, all over the bottom function squared. So you do have to know this quotient rule formula. It's one of the more elaborate ones that we have to remember, but it's not that bad. Just have to make sure you get the subtraction the correct way. Okay, so the derivative of the top function, right? E to the x is the top function times the bottom function minus the top function times the derivative of the bottom function, all over the bottom function squared. Of course, the derivative of e to the x, remember, is just e to the x. That's the exponential function rule. It's not a power rule. And we don't bring the x down, e to the x minus 1. That would be incorrect, right? The power rule is here. We have x is the base, right? The variable is the base, and the exponent is a constant. So the derivative of x to the fourth, that is 4x cubed. Derivative of 1 is 0. So I get 4x cubed for that derivative. And then just clean this out, distributing the e to the x through here and distributing this negative e to the x here. I don't want to expand the x to the fourth plus 1 because it's already factored. But could I factor the top? Well, I can factor out a GCF of e to the x, right? I can pull out e to the x. I'm left with x to the fourth plus 1 minus 4x cubed. And then if I could factor this any further, I would. I'm just going to rewrite this x to the fourth minus 4x cubed plus 1, write it in descending order. But there's no common factor there, and this is not in a form that looks like I can easily factor it. So I would stop there at that point, and this then would be your final simplified result. Okay, hope this is helpful for this problem.